Okay, so we're going to look at function notation. This example, they've given us a word problem. And the first thing we're going to do is create an equation from the word problem. And then what we're going to do is we're going to put it into function notation and try to make sense of it. So the question reads, there's a mine in South Africa called Western Deep that is being burrowed down to 4,100 meters. Suppose the temperature at the top of the mine is 11 degrees, and the temperature drops by 0.015 degrees per meter as you descend. So this could be confusing. We haven't worked with this stuff in a bit, but essentially what this is a linear equation. Okay, and what it says, if we were to put it as a linear equation where we use y equals mx plus b, y equals mx plus b. Change these colors. I'm sure we started, so that helped, but plus b. Okay, b would be our y-intercept. So what we're going to do is we're going to think as our y-intercept as being the temperature at the top of a cave, right? Imagine we're in some cave, and our y-intercept is where we enter it. All right, we would never be above that, right? We would never be outside or floating above the burrow of the cave. We'd be on the Earth's surface right at that cave. So our y-intercept is that. And it turns out our y-intercept, the temperature is 11 degrees. Okay, so that's the highest temperature we're getting. Let's say drops or increases? Sorry, it definitely doesn't drop. Sorry, I wrote that word down wrong. It should be increases. I'm just going to put an arrow, increases, okay, by that much. Because as you go closer to the center of the Earth, it gets hotter and hotter. It doesn't drop in temperature. Anyways, so our y-intercept, or our lowest temperature, is 11 degrees. So our b is going to be the value of 11. And our slope is what it's dropping by. So it's going to drop by 0.015 degrees. Okay, so we'll make that in blue. 0.015 degrees. Now we still have our y and our x, but what we want to do, so y equals 0.015x plus 11, so I'll rewrite that so it looks nice here. Y equals 0.015x plus 11. So we've built this, okay? And that's not really what we're focused on. What we're trying to focus on is putting this in function notation. And a lot of times in function notation, they'll name a variable to reference part of the question. So in our question, we're going to say that our x is our degrees, right? Because not our degrees, but our meters here. Our meters, depending on how many meters we descend, our degrees are going to drop, okay? And I'm going to stop. So we have our linear equation. Now, function notation is essentially the idea that we replace y with two letters. And the letters are commonly known as f at x, okay? And what this means is f represents this equation. You can represent many different equations, and x is the variable in the equation. So x is our input, and f at x, so the whole thing, is our output, okay? So this is hard to imagine, but what we're going to do is apply it to this equation. Okay, if we were to call this f at x, so we replace the value of y with f at x. Okay, well, what this is our function. Our function, or the equation, is 0.015. The variable in the equation is x. Okay, so the function itself, so f at x, is equal to all of this, and the variable in the equation is the value of x. Now the reason we write it this way is so that we can substitute values into this and keep track of what we're doing, what values we've plugged in. So for instance, maybe I want to find f at 0, okay? So the way I would write this out is I'd say f at 0. And what that means is I'm replacing the value of x with 0, or in other words, we're finding when x is equal to 0. Now in this case, when x is equal to 0, do you know what this function would be? What f at x will equal?
0.
Yeah, so, well, not quite 0. It'll actually be, this will cancel out, and we'll get 11, right? So at 0 meters, which is the mouth of the cave, the temperature is 11 degrees. That makes sense. And the reason we write it this way is so I can look at the final answer, and I can tell you everything we did in this question, okay? I knew that I plugged in 0 for the variable, okay? And the final answer, so I plugged it into this function, whatever that function was. When I plugged 0 into that function, the output was 11. Okay, but we can plug other numbers into this and find similar information and compare it easily. So for instance, let's say we look at f at 1,000. We want to go a kilometer into the ground. Well, we know that our function is 0.015. We would replace x with 1,000, okay, plus 11. So f at 1,000, so we plug the value of 1,000 in, we move this over 1, 2, 3 times, it becomes 15 plus 11. So the temperature when we go 1,000 meters deep is 26 degrees. Okay. So in other words, what this told us is we inputted 1,000, so we went 1,000 meters, we inputted into this function, and we got 26 degrees as our output. Okay. Now the reason we use letters to deal with functions is because what I could do is I could also add something else to this. I could say that there's another cave, and this cave, the temperature at the end of this cave, when you enter it, is maybe 15 degrees Celsius, and for some odd reason, this cave's temperature increases a little faster. It increases at a rate of 0.2 Celsius per meter. Okay. Well, let's say I wanted to build an equation of that, but I still want to keep track of everything I've done before. I don't want to call it f at x, right? Because f at x is this equation. It's very different. So I use another letter to represent f. So maybe I decide to use the letter G. Okay, and I'll do it in a different color for now, but essentially the idea is if you don't have colors to represent different equations, we use these letters. So G at x, we're still dealing with the same variable, right? That x is meters under the ground. G at x would be equal to the same idea, 0.02x, this time plus 15. Okay, so g at x, this g is a completely different function. G at x is equal to that, while f at x is equal to 0.015 x plus 11. So the idea here is within these two equations, I can see without really having any other background that we're comparing the same variable, but they're into two different equations. This equation, which we can clearly see, is different than this equation here. And depending what we plug in, our temperatures will change, right? So maybe at some point I want to find at 2,000 meters. So at 2,000 meters, what would G at x be? Well, if we were to go 2 kilometers into the ground, okay, we get 0.02 times 2,000 plus 15, right? This ends up being 4, and we bring it over 1, 2, 3, so that becomes 40 plus 15. We get 55. So 2 meters into the ground of this cave, which is a different function, we're at 55 degrees. While if we used the other cave, because we're using the other function at 2,000, 0.015 makes 2,000. Is the substituting making sense? It's just kind of an addition to what we're doing. This would give me 3, so I think it gives me 30. 11, this becomes 41. So in this other cave or this other function, when I plug 2,000 in, I get 41. So the function notation, the f at x, the g at x, those are essentially your y values if you're graphing, but they're there to represent different functions or different equations. Okay?